Climate change affects weather in two main ways. The first effect is the warming effect. Because the atmosphere contains more greenhouse gases, the atmosphere overall increases in temperature, and so does the likelihood for heat waves. A warmer atmosphere can also hold more water vapor, and that needs to get out of the atmosphere as rain, and so on average we see more extreme rainfall. A second effect is the dynamic effect. Because we have changed the composition of the atmosphere, the way weather systems develop and how they move changes. This effect can be small or big and is very different from region to region and from season to season. These two effects can push in the same direction, so you get even more warming than you would expect from the warming effect alone, but they can also work against each other. So you might expect more rainfall because of the warming effect, but because you get fewer dynamic weather systems conducive to rainfall, you have overall no change in the likelihood of extreme rainfall. In short, we can't say what the effect of climate change is on weather without looking at the data for a specific region and a specific season. However, we can do exactly that. We can simulate weather using advanced computer models. By simulating possible weather over and over again, we can work out what the likelihood of the event, of the intensity we have just experienced, is to occur in today's climate. So to work out how much of an impact climate change had on the weather, we can repeat these experiments and simulate possible weather in the world that is exactly as our world today, but without climate change. And because we know exactly how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, we can remove the from the model's atmosphere, and so simulate a world that is 1.2 degrees cooler. And then again, find out what the likelihood of the event we have just experienced in this world without climate change. And if they are different, we can attribute this difference to climate change, because that is the only thing that is different in our two simulations of possible weather. Using these methods, we have found that climate change is a real game changer when it comes to heat waves, making them 100 and more times more likely in many places. For other extremes, like the intense rainfall associated with Hurricane Harvey in 2017, climate change made the event 3 times more likely. The similar result was reached for the Cape Town drought in the same year. For other events, like the recent droughts in Eastern Africa and also a drought in 2014 in Brazil, climate change did not play a major role. We do not yet have a complete overview of what the impacts of climate change are worldwide. But within the last 5 years, we have developed tools and understanding of how climate change affects weather in the places where we live and where decisions on adaptation are being made. At COP26 this year, I hope that this evidence is being used to really up the game on adaptation and adaptation finance.